Welcome everybody. In this video we're going to find the second derivative of y by using implicit differentiation. So start with equation x cubed plus y cubed equals 1. And before we can find the second derivative, we have to find the first derivative, dy dx. So we differentiate both sides of the equation with respect to x. On the left-hand side, we're doing derivative of x cubed plus derivative of y cubed, and derivative of 1 on the right is just 0. So using implicit differentiation, since we're doing derivative with respect to x, derivative of x cubed ends up being 3x squared, derivative of y cubed ends up being 3y squared times derivative of y. So we get in 3x squared plus 3y squared times dy dx equals 0. If we divide through by 3, we have equation x squared plus y squared times dy dx equals 0. And so subtract x squared from both sides, and then divide by y squared. We get that dy over dx is equal to negative x squared over y squared. And now we're ready to get the second derivative. So to get that, we differentiate the answer yet again. So second derivative is derivative of the first derivative, so that's derivative of negative x squared over y squared. And so continuing that, we can pull out the negative sign, so it's going to be negative derivative of x squared over y squared. And using the quotient rule, we see negative fraction, derivative of x squared times y squared, minus x squared times derivative of y squared, divided by y squared squared. And that ends up being negative 2x times y squared, minus x squared times 2y times dy over dx, all of that divided by y to the 4th power. And to keep going, we can actually simplify these quite a bit. We use the previous answer, that's dy over dx being equal to negative x squared over y squared. And we can rewrite the answer for second derivative by replacing dy over dx with negative x squared over y squared. Okay, so if we do that, well, first of all, we have the double negative. So we're going to simplify that, and then we have y and y squared here, so we can cancel that out. And since we still have y in numerator showing up in small denominator, we're going to go ahead and multiply the big numerator and big denominator by y, so that we get something like this. Y to the 5th downstairs, y cubed here, and then we have all of these multiplied by y. So that gives us cancellation of y. And we end up having negative 2x y cubed plus 2x to the 4th. All of that divided by y to the 5th. And if we factor out 2x, we have negative 2x multiplied by y cubed plus x cubed, all of that divided by y to the 5th. And if we use the original equation that connects x cubed and y cubed, we see that x cubed plus y cubed is equal to 1. So this parenthesis could be replaced by 1. And we end up having a pretty simple formula for second derivative. So it's negative 2x divided by y to the 5th. So second derivative is equal to negative 2x over y to the 5th in this problem. In this problem, we're going to find second derivative using implicit differentiation. In the case of the equation, square root of x plus square root of y equals 1. As usual, we start by finding the first derivative. So we're doing derivative of x to 1/2 plus y to 1/2 equals 1. So splitting, so derivative of 1 will be 0. And on the left-hand side, we have the sum, so doing derivative of the first term plus derivative of the second term. And then, since we're doing derivative with respect to x, derivative of x to 1/2 power gives us 1/2 times x to negative 1/2. And derivative of y to 1/2 power gives us 1/2 times y to the negative 1/2 times dy over dx by the chain rule. So if we multiply by 2, we end up having x to the power negative 1/2 plus y to the power negative 1/2 times dy over dx equals 0. So if we move the we can do two things at once. So this x to negative 1/2 power is the same as 1 over x to 1/2 power. And we can move that term over, and that thing picks up the negative sign. And then y to negative 1/2 power is 1 over y to the positive 1/2 power. So then, if we multiply both sides by y to the 1/2 power, we get the expression for dy over dx, which ends up being negative y to the 1/2 power divided by x to the 1/2 power. So now we're going to differentiate again to find y double prime. So this is derivative with respect to x of negative y to 1/2 power divided by x to 1/2 power. So take out the negative out of the derivative and then use the quotient rule. So we're going to have derivative of y to 1/2 power times x to 1/2 power minus y to 1/2 power times derivative of x to 1/2 power divided by x to the 1/2 power, all of that squared. So using the implicit differentiation, so derivative of y to 1/2, just like we did before, gives us 1/2 times y to negative 1/2 times dy dx, and this x to 1/2 power was around. Okay, and then we have derivative of x to 1/2 power, that's 1/2 times x to negative 1/2 power. And in denominator we just get x, because x to 1/2 power squared is just x. Okay, so now to simplify this further, we use that dy over dx is equal to negative y to 1/2 power over x to the 1/2 power. So we're going to replace dy over dx with negative y to 1/2 power over x to the 1/2 power. And so this negative sign could be brought out in front. So we have all of this, and then x to 1/2 power times x to 1/2 power is going to cancel. Well, before we do that, we can cancel all those negative signs, and then x to 1/2 power cancels. So then we have this expression, and then again y to the negative 1/2 power. Well, okay, so we're going to multiply by 2 so that there are no 1/2s in here, but then y to negative 1/2 power times y to the positive 1/2 power cancel each other out. So all in all, we're looking at expression 1 plus y to the 1/2 power times x to negative 1/2 power divided by 2x. Since we have x to negative 1/2 power, we can multiply numerator and denominator by x to 1/2 power, distribute it over, cancel, and we're looking at x to the 1/2 power plus y to the 1/2 power divided by 2x to the power 3/2. And then square root of x plus square root of y is 1. So this x to 1/2 power plus y to 1/2 power becomes 1. We have 1 over 2x to the power 3/2. So the second derivative becomes just 1 divided by 2x to the power 3/2.